Good morning. Starting Unit 11, which is trig identities. We'll talk about what that word means in a minute. I'll remind you, if you haven't looked at a calendar recently, we're going to start today, Monday, go through the 23rd. That's next Tuesday. We'll have a review day on Monday. So we should have plenty of time to catch up, regardless of how many days we miss this week from school. We'll be okay. We'll have time to catch up. So trig, we know what that is, short for trigonometry, sine, cosine, tangent, secant, cosecant, cotangent. We're somewhat familiar with those. Certainly you've heard them all. You've used them a little bit. Identities you've used before, but we may not have used that word, and so people don't know exactly what it means. An identity is a statement that is always true, which is, I don't know, I guess maybe seems simple. An example that you already know would be x times x equals x squared. And now it's almost like, who cares? Of course that's true. And some of the identities we'll look at, especially today, are the simple ones, and yet you'll know, because of how we've learned them so far, you'll know, you're going to know, I think, all of the ones we'll look at today. And so today will be not so much about the identities we learned, but how do we use them. So that's the kind of the outline for today. Is first, what are the identities, and then second, how do we use them. So the identities for today are, I guess, in two categories: reciprocals and then tangent and cotangent. Again, you know these already, so I'm going to write them down, but these should be hopefully immediately familiar to you. Cosecant is the flip of sine, so 1 over sine of theta, which means that sine is the flip of cosecant. So you could phrase that either way. That's an identity pair that go together. You might can guess what's coming next. Secant is the flip of cosine, and its pair would be that cosine is the flip of secant. Again, I think we know those already. I hope we know those already. Cotangent is the flip of tangent, and tangent is the flip of cotangent. I mean, that's how we learn these things from the get-go. When we were writing down the 6 sine functions, or the 6 ratios, we learned them as who their reciprocal partner was. So I think we know this already. The second set are tangent and cotangent. You know these already as well, I think. Tangent, if we think unit circle, although some people remember it as y over x, which is fine, but that's also sine over cosine. And so it's really helpful to know today that tangent is sine over cosine, and that means that cotangent is cosine over sine. So those are 8 trig identities, 8 statements that are always true. It doesn't matter what angle we're talking about. Cosecant is always 1 over the sine. Like, by definition, these things are always true. And again, the good news is I think you already know all of those things. So that much, I think this part of it will be easy. The hard part will be what we do next. In the coming days, we're going to add some identities to these that are a little bit more complicated. But, one day at a time. We'll get to those later. What we'll do with them, and you'll see this in the instructions, certainly on today's worksheet, and I think even on subsequent worksheets after that. Yep, some of them say verify. So verify means the statement they're going to give you is true. So it's not like true or false, or they're trying to trick you, or does that really work? No, the statement we're going to give you on today's worksheet, there's 10 of them, they're all true. And so your job is to show that it's true. So verify just means show it's true, and you're going to show it's true using the things that we already know. So, some examples. sine of x over tangent of x equals cosine of x. And we want to show that that's true. Now we need to do some ground rules on verifying, I think, before we start. One rule is that we always want to work on only one side. Now, sometimes that's easy to do, other times that's a little trickier to do, and when we get to the trickier ones, I'll show you how to kind of cheat the system and work on both sides and then get it all on one side. Today it won't be too bad, but this keeps our work neat and clean if we only work on one side. So you pick one side to work on and try to make it look like the other side. I don't know if that's number 2 or not, but work on only one side to make it look like or equal the other side. Now the question then is, well, which side do I work on? How do I know? Should I work on sine over tangent or should I work on cosine? The short answer is you could always work on either side. There's never a right or wrong choice. There's usually a better choice. And the better choice is to pick the most complicated side to work on. Pick the most complicated side to work with or on. Because it's easier to simplify a side than to sort of expand a side. So just looking at example 1. Even if it's our very first one, cosine seems pretty simple. Sine over tangent is not that difficult, but it's more complicated than cosine. So I think I want to work on the left-hand side on this one. And it'll be easier to fix the left than to fix the right. It's easier to fix the more complicated one than to fix the simplified one. Because what in the world am I going to do with cosine? There's nothing I can really do with that. I mean, there's some tricks I could do with it, but I usually want to pick the more complicated side and work to simplify it to match the easier side, the simpler side. So we'll do that with this one. So I'm going to leave cosine alone. I'm going to only play with the stuff on the left, and hopefully eventually it looks like cosine. In some ways this is good news because, like, you know the answer. It's like, this is the problem, sine over tangent. So fix that, except that the answer is cosine. So your job is to show the steps of how do I get from this to this. A frequent option, not an all the time option, but something that usually works, especially will work today, is to put all functions in terms of sine or cosine. Right, we hadn't talked about this yet, but you can write all 6 of the trig functions can be written in terms of sine or cosine. Right? Sine and cosine are obviously just themselves. Secant and cosecant are flips of sine or cosine. And tangent and cotangent are a ratio of sine over cosine or cosine over sine. So one way to, I hate that I listed that at number 3, like that's always, it's an option. That's sometimes a good option, and that is to put everything in terms of sine and cosine and hope that it works. So let's try that on this one. So sine of x over, well, tangent is sine over cosine. Okay, well that looks a little bit weird, and I don't want to be canceling things and then I'm not sure where the cosine goes, so let's do the keep it, change it, flip it. So keep the top, change its multiplication, and flip the bottom. Right? That's just good old algebra. Keep it, change it, flip it. And notice I'm not doing anything to the right hand side. I've committed to work on one side. I'm only going to work over there. In fact, some people will draw a line to sort of emphasize which side I'm working on. The signs will cancel, and I'm left with cosine of x equals cosine of x. Now, this one was pretty straightforward. You're always going to get, the bottom line is always going to be cosine equals cosine, and so some of you are going to try to kind of fudge your way through it because you know this is going to be the answer, and you're going to have a bunch of mishmash nonsense in here and hope that I just look at the answer and check and give you credit. I'm not, because the whole point of these is to show your work through these steps and to show carefully, neatly, cleanly, what you're doing to make this side equal this side. So cosine equals cosine, we know we did it, we know we're good on that one. Let's try another one. Tangent of x over cosine of x equals secant of x over cotangent of x. Whoops, you can't see that. Tangent of x over cosine of x equals secant of x over cotangent of x. Alright, I'm only allowed to work on one side. I want to pick the harder side, or what looks to be the more complicated side. Well, both sides have two trig functions, so I don't know which side's more complicated on that, but I would certainly say that secant and cotangent are both more complicated than tangent and cosine. So again, you can pick either side to work on, but I think secant and cotangent, those are kind of weird. So let's work with those and see if we can turn this side into this side. So this time we're going to work on the right hand side. So it's not about am I working on the right or the left, it's about which side's more complicated, because that should be the easier side to work with. Alright, secant and cotangent. I don't know that this is anything in particular, but I do know that one way to rewrite secant, go color code here, one way to rewrite secant is 1 over cosine. And one way to rewrite cotangent is cosine over sine. That's what cotangent is. Okay, well this looks like kind of a mess here. But again, I know the answer. This is what I'm headed toward. So some people don't like these verify problems. Other people like them because I know what the answer is. It's like I'm looking in the back of the book and they told me what I'm going to, so I just got to show the steps to get there. I think maybe we treat this one as another keep it, change it, flip it, like an algebra step. So I'll keep the top, change it to multiplication, and good old keep it, change it, flip it, and then I'll flip the bottom. So that would be sine x over cosine x. Maybe I should have kept the color code there. So that was the blue one. Cosine was this one. And again, I keep looking over here, so I don't just, it's not like I cover this up and work on one side and hope to magically make it appear. Like, I'm intentionally, you have the other side. It's not cheating. The idea is to get there. So, like, you want to keep looking where you're going, right? That's the goal. You don't just take off somewhere and hope you land at the right spot. Like, you look at where you want to go and you keep that in mind. So after each step you do over here, you keep looking over here and say, well, am I close? Am I close? Does something match? It's like, well, something does match. I got cosine in the bottom. That's good. That kind of matches. Sine over cosine, I know how to rewrite that. That's the same thing as tangent. So now I got cosine in the bottom, tangent in the top. That's exactly what I want. But you're not done until they match exactly. So you're like, well, obviously those are the same. Yeah, obviously they are the same, but they're not the same yet until you write them so that they are exactly the same. So tangent of x over cosine of x. And I rewrote it on the first one. You don't have to rewrite it because they are equal, so we're good on that one. Again, pick the hardest side to work with. One of the options is to put everything in terms of sines and cosine, and then use your algebra. Keep looking at the finish line to know where you're headed, and hope that things work out. Again, they're all going to work. This isn't true or false. There's not any tricks. Occasionally, the only tricks are if your teacher makes a mistake and puts one on there that's not true, which has been known to happen. Not intentionally, of course. So if you ever get one that doesn't work, you're welcome to check and ask me if I'm sure that that's a right one. But so far, all the ones I've checked are good. All right, example 3. 1 over tangent of x equals cosecant times cosine. All right, pick one side to work on. Pick the more complicated side. I think this side is going to be more complicated. There's two things there. Cosecant's kind of weird. So I think I want to work on the right hand side and hope that 1 over tangent shows up. So cosecant, that's partners with sine. So I could rewrite cosecant as 1 over sine. Cosine, I can't really do anything with that. That's just cosine of x. Cosine over sine. Okay, I'm close. Actually, I'm close here because cosine over sine, cosine x over sine of x, that's cotangent, which is the flip of tangent. You're not done yet, though. Again, it's tempting to say, look, those are the same. Like, I know they're the same, but you have to write the final step of whichever side you're working on has to match exactly what you started with. So we said earlier one of our reciprocal relationships was that cotangent is 1 over tangent. And so now they're exactly the same. Now we're good. Let's do a couple more. Again, some people really get the hang of this and honestly kind of like this unit. Others, not as big a fan. But we'll see. See where you sit on this. All right, cosecant minus 1 equals 1 minus sine over sine. Well, again, you can work it either way. You can work on either side. And by the way, when you're comparing notes with a friend, or even if you're comparing your work to mine, there's always two ways to work these, because again, you can always pick either side. And so if you're comparing with a friend or you're working together or comparing against mine, you may still have the right answer even if you pick the different side to work on. Cosecant's complicated, but this one's a fraction, so I'm going to say that the fraction trumps the cosecant thing. But if you start on this side, you can get there. I'm going to start on the right hand side on this one and use my algebra. It helps that I know the properties well enough to kind of peek ahead and see that, well, this is 1 over sine and this is sine over sine, and that's pretty much what this is. I'm going to split this up. Just algebra here. They're both over sine, so I'm going to write them separately. And then I'm almost there, because 1 over sine is the same thing as cosecant, and sine over sine is 1. So that actually turned out to be a pretty quick one. You know what? I'm going to do it the other way as well. So that's it, I'm done. This is going to look, well, here, I'll do it the other way with on top of this. So I would not write this down, but I just want to show you that you could work the other side and get the same answer. Or it's a different approach, but it still works. Let's see, cosecant is 1 over sine. So 1 over sine of x minus 1. Well, if I'm looking over here I've got two fractions, here I've got one, so to go from here to here, I think I need to combine this side into one fraction. Well, one fraction means a common denominator. So put sine x in the top and sine x in the bottom. Now I got a common denominator of sine of x, so I can write that as my denominator. My numerators I can just subtract 1 minus sine of x, and that's what the other side has. So that's a good one to show that you can work on either side, and it's the same number of steps. It's just one's a little different than the other, and I don't know that one is even better than the other on that particular example. All right, last example. Secant x plus tangent x over secant x sine of x plus 1. Again, decision number 1 is which side do I work on? Again, the more complicated side is usually the best choice. Again, they're not a right or wrong choice, there's just a best choice, usually. And this one, this side looks way more complicated than this side. Sine of x plus 1 looks pretty simple, at least as far as these things go. This has some crazy stuff in it, but if I'm peeking ahead, like secant over secant, that's where the 1 will come from. Tangent over secant, I don't know what that is, but we'll see what happens. So I think I want to work on the left-hand side, partially because I can see right away that secant x over secant of x is going to be 1. So the 1s are starting to match up already. So I feel like I'm close anyway, or at least I got that much done. Now, how does tangent of x equal secant of, or tangent over secant equal sine? Let's write everybody in terms of sines and cosines and see what happens. Tangent I can write as sine over cosine. Secant I can write as 1 over cosine. Some people can simplify from there. Their fraction sense is good enough that they see that cosines are both in the bottom, they cancel them. Other people are a little more hesitant to do that, and they'll do the keep it, change it, flip it thing. So keep the top one, change to multiplication, flip the bottom one. And again, I'm peeking over to the other side. That's not illegal. That's what I'm supposed to do. I'm cheating. That's my goal, so it's okay to look there. I'm almost there. So the cosines will cancel. Again, they have to match exactly. So yes, I know that 1 plus sine equals sine plus 1. That's actually an identity. But because this section is on identities, I need to rewrite this side as sine of x plus 1. And now they match. I'm thinking, would it be possible to work this side to get to there? Yeah, but it would be a pain to do it that way. This one would not be easy to go to work on the right hand side. So sometimes it doesn't matter which side you pick. Other times it matters a lot. Not in terms of right or wrong, but in terms of ease or difficulty. All right, today's assignment is Unit 11, Worksheet 1. I've posted the entire packet. I would not print out the whole thing because hopefully we'll be in school in tomorrow or the next day or whenever, and I can give you the packet. So I would open up the packet, print off Worksheet 1, which I think is the first 2 pages of the packet. Yep, 2 pages, 10 problems. Some of them are very similar to the ones that we did, and I will post the odd answers as well so you can compare. Again, though, there's more than one way to skin a cat on these trig identities. So give those a go. Also, there's a Schoology quiz that you'll see. It's just a daily grade. It's just a little quick check on what you're doing. I think you'll find it pretty easy. But open that up and do it. It's 5 questions. It probably won't even take you 5 minutes to get through it. So good luck. Hope this didn't take too long. The worksheet won't take too long. I hope to see you back in school soon. In the meantime, I hope it's nice and fun outside and we get to play around a little bit and enjoy the extreme temperatures. So stay warm, stay safe, and I hope to see you soon.